Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Welcome, everyone. Today we have Brian Keegan. He's a data scientist or network scientist. He's a postdoctoral researcher in Northeastern University with David Lazar. Is that how you pronounce it?
Yeah.
Lazar? Right. David Lazar. And he got his PhD in Northwestern University. So he's going to talk about narrating with data today.
Thank you, Andres. Well, thank you all for being here. I'm excited to be here and talk about some of my work. This is actually the sort of first time I'm giving like this version of the talk, so hopefully you guys won't begrudge me when you see another version of this probably 5 years from now as I refine it. So this is just an outline of my talk, and we'll come back to this slide more and more. But I want to sort of give you a little bit of context from where I come from in network science, particular type of network science that I do. They go into sort of the event log data that I like to work with and how I kind of turn these into socio-technical trajectories. Then I go through 3 different cases and sort of at differing levels of abstraction from very sort of fine to very sort of macro level of what we can do with this socio-technical trajectory approach. And then we'll wrap up with the discussion. And so I differentiated on that first slide between sort of network science and network theory. And so when we think of network science, we usually think of someone like Professor Barabashi here, who has been very sort of instrumental in sort of thinking about how do we sort of model networks and develop sort of statistical models of networks. And they're very much sort of concerned with how examining the similarities across different kinds of networks. That if we look at biological or social information networks, we see very sort of similar patterns in the topology and the structure of these networks. They're scale free and they have sort of very sort of skewed degree distributions like that bottom image there. But these models that they often sort of instrument coming from sort of the physics side of things usually assume that people are sort of protons or proteins or particles. They don't really sort of differentiate between what it is that we're modeling and the interactions that we're modeling here. But they're very sort of interesting and powerful models because you specify sort of these microscopic models of like how a single node behaves and how they sort of make individual sort of choices. And you're able to generate these very complex sort of macroscopic sort of processes. But this whole sort of domain of network science really ignores sort of a lot of the economic and political implications of what these network features mean. What does it mean, for our society or for our legal system or for how we allocate resources to have something that is sort of skewed in these sorts of ways? We just kind of, they come from a perspective like this is what it looks like, and let's try to explain that. On the other side, we have someone like Professor Benkler here who also talks about networks. But he talks about networks in a very different way, in which how do sort of new information technologies enable us to sort of develop new forms of organization, new ways of knowledge production, and very much focused on these questions of sort of what are the economic, legal, and sort of political implications of having a network political economy. What does it mean to have a Wikipedia or a Linux or something where people are able to sort of collaborate in large ways to kind of create new forms of knowledge and these sorts of artifacts. I don't know if I'm allowed to show the Linux penguin here at Microsoft. But he also is sort of very concerned with not these sort of microscopic questions like how do nodes make links to each other, but these macroscopic sort of concerns about what does it mean to have like a polarized blogosphere, like this image from a lot of Adamich's work back in 2005. And but at the same time, like when he talks about networks, he doesn't talk about it in the same way that Barabashi would talk about it, where we're looking at sort of the particular kinds of structures and how are these networks similar or different. So Benkler sort of ignores these sorts of what are the network features that generate these kinds of particular Wikipedia or Linux. Are Wikipedia or Linux similar? Are the way that they collaborate similar? What does that mean for them to be similar or dissimilar? And so beyond sort of the need that we need to sort of reconcile the fact that we've got social scientists and physicists kind of doing these different sorts of things, different methods. Benkler on one hand, they don't speak to each other often about what it is that these networks, they both talk about networks, but they talk about networks in very different sorts of ways. And so Benkler talks about like he's really silent on what does it mean for these different sorts of collaborators, how do they sort of form into cohesion, how do they produce this knowledge, what do those structures look like, how are they different. Barabashi's really sort of quiet on the fact of what does it mean for the implications, what are the outcomes of these network processes? What does it mean for these networks to sort of, what is it that they kind of produce? And so I think we need to And what I'm going to talk about here is how we're going to sort of understand the structural characteristics of self-organization in a variety of ways, and how we can develop some methods that allow us to compare how do we observe sort of self-organization in sort of these large-scale socio-technical systems. In particularly, sort of this idea of stigmergy. And so this is sort of a theory from biology where sort of there's actors in an environment, and they self-organize and they coordinate their work not by sort of directly communicating with each other, but actually sort of modifying the environment around them, and then they sort of incrementally build upon other people's contributions behind them. And so you get incremental contributions in the shared information environment are the ways that work is coordinated. It's not through sort of direct communication. And so how do we sort of, and so my assertion is that we would see sort of similar sorts of processes of stigmergy happening in these socio-technical systems. It's not sort of direct interactions what we want to look for, but rather sort of the processes of modifying each other's work is what's the sort of the operant relationship that we should be examining here. And so to do that, I want to sort of go over what an event log is and what event logs are in a variety of different sorts of systems here. And so in Wikipedia, if you go to any sort of Wikipedia article, you can go and click on the revision history, and you'll get sort of a segment that will look like this, where you've got a list of all the different contributions that an editor's made. So in this case, you've got editors who are IP addresses or bots or a person right here with a timestamp, and they're adding content, they're removing content, and you can compare the differences between that and the previous version. We could do that on something like GitHub, where there's also event logs that sort of document all the changes that have been made to a particular code repository. Again, you've got a person making a change. You can look at the sort of the difference between that with a timestamp and this particular kind of action, like an edit or a commit. On Reddit, you've also got people who are participating in kind of creating a comment thread and sort of the coherent that allows us to sort of see, it emerges into this whole sort of narrative of people interacting and producing this one kind of sort of knowledge artifact in a way that the whole thread is something you could sort of read through. But again, they're sort of modifying the previous person in the thread with a timestamp and so forth. Or even something like Scratch, where you can go through and see whether or not people's sort of history of the changes that they've been making to the system as a whole, if they've been loving or favoriting or liking something in an online community like Scratch. So with all these event logs, we have these sorts of activities that people take, that they make a commit, they make a revision, they make a comment within a system, and there's records of that. That there's a case that they're doing this to something, that it could be to a repository or a particular code bank, it could be to a Wikipedia article, it could be to a discussion thread on Reddit or something like that. We've got a record of a performer, like who is actually doing this. It could be a user on GitHub, it could be an editor on Wikipedia, it could be a member of an online community, it could be a human editor, it could be a bot, an automated sort of entity. Then we also have an order, that we have sort of these things happen in a sequence, and this is sort of really crucial, and I'll explain why in a second, that you can sort basically these records in a way based on time or in position or depth on a thread, and that this time order is actually can become very sort of interesting, is that if you do sort it, if you take sort of the Wikipedia history log here, or a GitHub, where you've got sort of people making commits to a specific sort of Wikipedia article, for example, and editor A made a contribution to article X at time 101, at time 202, we see this sort of event log sort of emerge. And so this is sort of the general abstract way that we can look at an event log. But I'll explain why sort of this temporal ordering is important in a second here. And this is what sort of the socio-technical trajectory is, that the core is sort of looking at these relationships within these event logs. And so before I get to that, I want to talk about, when we've looked at sort of, the scholarship has looked at sort of the socio-technical systems before, they very much are sort of focused on, these questions of self-organization and hierarchy that I'm also interested in, of open source systems and so on. So there's a huge sort of literature on this, but sort of the relationships that they look at here are often this relationship of like who works on what articles. So it's user A, so you've got a node who's a user and another node who's an artifact. So user A might have a relationship with an artifact that user A is making a contribution or an edit or a commit or something to artifact X like that. And then so you say, well, okay, we can mine that event log, we can take all these different relationships, and we can create some beautiful picture like this. And you're like, wow, you've got all these red nodes, they're like the articles on Wikipedia, and the blue nodes are the editors who are editing them. And you see like, oh, there's like this complexity and heterogeneity, and there's some clustering down here, and there's some other ones that are kind of isolated, but they're all sort of connected, and you can do all these sorts of really interesting network analysis. But if you wanted to kind of zoom in and like look at what did the collaboration look like on one article. It's like, great, we can do it across a bunch of articles. That's really interesting. But what does it look like on one article? So if we go back to that sort of event, the article trajectory, or the sort of this individual sort of history of contributions, you know, the way that we do that sort of traditionally is we'd say, like, okay, at time 1, like, editor A made a contribution to article X, and at time 2, B came along and made a contribution. At time 3, C came along and made a contribution. At time 4, A came back and made another contribution, so maybe we make that line a little bit thicker, but it's unclear, like, the ordering, what, you know, we can't sort of discern what the ordering is in the system, and maybe D comes and makes another contribution, and maybe A makes the 6th contribution there at the end, and so in this, we see the emergence of a structure, but what comes out of that, if we're looking at just a single artifact, if we're looking at just how a single Wikipedia article or a single GitHub repo is edited, if we do this sort of metric, we get networks that look like this, where you've got the Wikipedia article or something at the center, and then everyone who edited it. And there's no sort of heterogeneity. There's nothing sort of interesting that's going on in terms of who's editing what or who's working with whom, right? You know, it's just sort of very simple sort of story. And so instead, is if we sort of draw on this other sort of literature about narrative networks and sequence analysis and process data, and we're looking at the sequencing of events, right? Like the interactions of like someone modifying after someone else, these processes of things unfolding and taking turns, and all these sorts of, there's this rich sort of literature on sequences and cycles and processes, right? So if we instead look to these things and ask a different kind of question of who modifies whose work, so it's not that like A is editing article X, but on article X, who's working with whom on that? And we in particular look at the sequence of events that user B modifies user A's version, that user B is editing immediately after user A. So like by implication, user B is modifying user A's state of the article. Instead, so those relationships begin to look like this, that you have this Aptiva is modifying Kenivo, so that he made a change at a particular point in time. It may not have been editing, you know, this particular set of phrases, but, you know, when he last touched the article, this is what the article looked like. And this guy comes through and just makes a quick change, like this stuff used to be all caps, and so he's going to go through and say, like, actually, let's kind of do it more traditionally, how we would write like a headline like that. And so the relationship here is that Aptiva is modifying, so Kenivo like owned the article for a brief point in time, like that's what the article looked like, and this editor comes along and modifies that state of the article, modifying what Aptiva had done before. And if we look at like GitHub, you can also see that, you know, we've got people removing some code and adding other types of code like this. And so when the previous person who owned this sort of article for however what brief time, some other person comes along and modifies that state of the article, right? So if we look at that in sort of abstract sort of trajectory approach, the relationships all of a sudden aren't that A is editing X, it's that B is following A and C is following B, and then A is following C, D is following A, and A is following D, right? So this is the sort of operant sequence, the relationships that we look at. But like, you also have this repeated sort of, you've got the same editors appearing or the same users appearing over and over again. So we can sort of collapse this down into a graph where there's only one kind of user. So like A only appears once, and then B modifies A's version, and C modifies B's version, and then A modifies C's version. And so we don't have another A that goes back to A. We create this cycle all of a sudden that the narrative comes out of the fact that we're not sort of like modeling sort of each sort of point in time that each individual edit, but that an editor owns a particular edit. That edit can come back to you or go away from you, but you sort of are represented in the same way over time. And so you have this cycle here where like people, it came back to A. A decided to jump back into the collaboration. He wasn't happy with what C had done, or he was happy and wanted to keep building on it. And then D comes along and wants to modify A's version, and A still doesn't like that. So what we begin to see out of this sequence all of a sudden is a much sort of richer and more heterogeneous picture of this sort of collaboration, where it's not the simple star anymore. You've got sort of rich, even from this toy example, much more sort of complex network emerging. And then if we actually sort of applied the sort of method to an article like Wikipedia, in particular a breaking news article, which is something that I'm very interested in, like how these collaborations on Wikipedia articles about breaking news events are different from other types of collaborations on Wikipedia. We look at sort of an individual article and we use this sort of method, we all of a sudden have a network that looks like this. That's sure, it's a hairball, but it's also much more complex and structured and heterogeneous. I can't pronounce that word today for some reason. Right. But so all of a sudden we have this network, and this is an article about the 2011 Japanese earthquake and tsunami. And so the nodes here, again, are the editors as before, and the relationships are if one editor modified a previous editor's version of that article. And so the nodes here are sized. How big they are is how many sort of other editors' work they've modified. But we can begin to overlay some more information on this, right? So we're going to dive a little bit deeper into this Japanese earthquake article. So this is the same image as before. And so I've only added the coloring of the nodes, but this isn't any sort of new information that we didn't already have in the event log. This isn't sort of new independent observations. What it is just that we're going to color the nodes a bluer color if they edited the article earlier, and we're going to color the nodes in a gradient towards like a redder color if they joined the collaboration, if they started editing later. So it becomes really apparent is that all of a sudden that in the very sort of early stages of this article, these blue editors working together when the article is very young, they're modifying each other's work in the first sort of hours or minutes after this event occurs. You see this very sort of dense pattern of work where they're sort of passing the article around to each other. And it's this very sort of dense pattern. You have this very prominent central person here is a blue editor. He or she joined this collaboration sort of very early. But then you also see these red editors out here, right? And so these people have a very different sort of pattern, right? So this is sort of like this hairball, dense, clustered, highly sort of cooperative sort of work. But out here, you've got these sorts of strings where sort of things get passed out, and so they look like these giant like orbits. And this is mainly just an artifact of the visualization sort of algorithm that I use to kind of spring embedding. But by implication, what it means is that these editors, this guy makes a revision, and this guy's modifying that guy's version, this person's modifying that person's revision. But the fact that you have this sort of string where like they make a revision, but then like no one else, all these other people who've made a revision, who've contributed something to this article, don't decide to jump in and like modify this person's version. They leave it to some other newcomer to come and modify that version. It says something really sort of deep about sort of the way this collaboration is unfolding, that these people have left the collaboration, and instead we've got sort of these new people coming in and modifying it, but they can't be bothered to sort of continue in the collaboration at a later point in time, because if they continue to collaborate, they would move to the center. They would be working with other people. They'd be modifying other editors' work as well. And so, okay. So we can sort of look at sort of different features of different things here. So we have like the first editors here. So these are, again, the first editors who made the earliest contributions to the articles. But they don't sort of persist. Like they work together very early on, but like as new editors came in and more work is being done, they're not here in the center. These editors left, right? They edited at a very early stage and didn't continue to sort of persist. We've got sort of core group of editors who are editing very sort of intensively with each other, and this is another group of early editors. Like I mentioned, we've got these sort of peripheral editors who join much later and are working together in a very different sort of way. Then you've got this one sort of highly central person who's making contributions. And then you've also got some other people out here who are sort of highly central, but like in a different way, and because they're surrounded by different colors. Like this blue person's working with other blue nodes here. They're working with other blue editors. They're working with other editors who joined relatively early. This editor is modifying the work of other editors who joined much later. And in fact, if you kind of zoom in and look at what he was doing, it's actually not a he or a she. It's a robot who's just modifying the work of vandals. These are people who joined very late. So he joined relatively early because of this greenish color. But then the only work he does is sort of modifying other sort of vandals. So he's reverting the work of other vandals. So if people come by and blank the page or say, that tsunami was awesome, they just try to undo that sort of work automatically. But we can also sort of color the nodes a different way. And again, we're not introducing any new information. We know like when the editor started editing, we know when the last observation when they edited. And so we can say, when did they sort of stop editing? So when was the last observation of when they were editing? So again, these bluer colors would suggest that they joined early, but they also stopped editing earlier. This person joined early as before, but this greenish color says he stopped editing sort of at a medium stage. But then you've also got these editors here sort of who were blue before, but are now sort of red. And they're sort of like the core editors. These are people who joined very early and are still editing much later up until sort of the present day. And so we begin to see the sort of the emergence of these social roles of people being custodians of trying to maintain these articles over time. We can do other sorts of layout algorithms here as well. But these attributes, there's other attributes that we can specify for these networks, right? So that because we're looking at these event logs, that we know like how much time has elapsed between edits, and that's sort of the operant relationship that we're looking at, how much time has gone on between these, we begin to say we can use that as another attribute that we can bring in. Like, so these relationships of editor B modifying editor A's work, that's editor B edited after editor A, but we can also say that editor B edited some time after editor A. We can put on like a latency. We can also go in and say what was the size of that difference of how much content were they adding or removing. Or we could even look at sort of the features of the content. So here is sort of the network as we had it before. And if we wanted to kind of just subset the data and just look at what does this network look like when we just look at relationships that are happening very intensively, very quickly, people modifying each other's work like in less than 60 seconds, then we again sort of unpack the sort of this backbone of work, you know, largely among the early editors, but we also see it among this Vandal fighter here. It has this sort of very distinctive pattern of sort of quickly modifying other people's work. We also see that this very sort of central person all of a sudden doesn't have that many strong ties anymore, but we do see very sort of strong ties out here, that these are sort of people who are editing very early on the article's history, but this is also when sort of the most intense work was going on, that people are trying to like work together really quickly and they're modifying each other's work, you know, like with less than 60 seconds going by. Then we can also look at this in a different way and say, like, let's just look at the subset of the nodes, just like remove a bunch of nodes here, and only retain the nodes if those editors have ever added more than, who've ever added more than sort of 50 bytes, like if they've ever added more than a sentence worth of content. So again, these are all the editors who've ever touched the page and ever made a change to the page. But if we ask the question, like, who's added more than like a sentence worth of content, all of a sudden this network becomes much more sparse, right? So the work that all these people are doing, that these other sort of 1,000 editors were doing, is incredibly sort of micro sort of level work, that they're changing particular sort of commas, or you know, they're doing stuff that's, you know, less than 50 bytes of work. And when you look at just the work of people who've ever added more than 50 bytes of content to this article, you get a sort of very different picture, and a lot of sort of very central people that we saw before don't appear there anymore. We still have these sort of two central people here. We're going to explore them in a bit. And so I pointed out those two sort of people at the bottom, and so just like I did before, is that we dove in and we looked at the event log for a Wikipedia article, or we could do this for any sort of artifact sort of event log. We can do the same for editors. We can do the same for users. We can say, we can go, in this case, this is my sort of edit history most recently, and so this is the history of all the stuff that I've been doing most recently, and we can go back and look at all 10,000 edits that I've made to Wikipedia. But we can again sort of go through and say, like, there's a relationship that I went from editing the article about John Riedel to editing the article about this WikiTalk page, and I did that after the social network, so I'm kind of jumping around to these different topics. But if we kind of aggregate that up and look at sort of the network of all these sort of relationships, what does that look like? So again, if I'm the sort of performer X, and instead of making changes to these different articles, we can model it the exact same way analogously, that I started editing at article A, then I jumped to article B, then C, then maybe I went back to A, then I went to D, and then I went to A. And all of a sudden we get networks that look like this. And so they're, again, these are sort of very unusual. Some of these features are sort of, we don't usually see in networks. You're used to seeing these sort of core periphery, or these complex sort of hairballs and things like that. But we see with some of these editors, we see very sort of these different sorts of patterns where you've got, this person was the sort of that steward, that sort of very strong central person up there. So this user's name was Flotted. So we can see where they started editing. So the initial edits that he ever made to Wikipedia was about the 2011 Tucson shooting. So again, these nodes are articles, they're not editors anymore. The relationship is if they edited one article after another. So his earliest edits are to this other sort of breaking news event. So he's editing this article about this breaking news event, and then, you know, that event sort of dies down. And he starts editing articles about like mobile phones, and so he's kind of like off in the wilderness. He's off in the wilderness, like literally like editing articles about Antarctica. And then the 2011, so the Tucson shooting happened in January, and the earthquake and tsunami happened in April. So when this happens, this event happens in April, this person all of a sudden like lights back up, and he's really in the thick of editing this article about this earthquake and tsunami. The articles that he's editing here, I've colored in different ways. So the blue articles are like the Wikipedia articles that we see. So these are like the front page, or the articles that 99% of us read and look at. The pink articles are the things that, like the talk page, where you have discussions about what we should do or what we shouldn't do. You've also got these brown pages, which are sort of more sort of highly specialized pages about sort of templates and sort of their infrastructure pages. Then you've also got sort of these turquoise pages, which are really sort of the pinker ones are sort of user talk pages, so he's talking to other users about what should be done. And then this light blue article is actually the talk page for that article. So we see this, he's jumping around, he's talking to other users about what they should be doing. He's jumping to the article about to the talk page, trying to get other people to work in a certain way. He's jumping to this other article about how do we sort of like get the number of deaths out and so on. And so this person engaged in this sort of very interesting sort of pattern of behavior that he did some breaking news stuff, then didn't, and then all of a sudden became very active and then did nothing else after this. Then we could look at other editors too. So there were these two other editors that we saw down here, right? So one of them is Sandpiper. If we do the same sort of method, we look at his history, what he's done before, we get this network where he started off editing articles about Harry Potter, and then he jumps up and starts editing articles about the nuclear disaster and the tsunami. And then he starts editing articles about Cutty-Sark, which is this British ship and also a kind of bad scotch. All right, but what's interesting is that the work that he was doing here on Harry Potter doesn't seem to qualify him all to edit articles about nuclear disasters or tsunamis or things like that. You know, Harry Potter is, on its surface, nothing really to do with a breaking news event. But at the same time, Harry Potter is something that's always in the news, right? It's like people are always kind of coming by like, you should put the spoilers in there. This article's, should have more stuff on Hermione, but not as much about Harry, whatever, right? So people want to use it as like a fan site or something like that. So the work that he does on the Harry Potter side is like being the dispute sort of arbitration stuff, that you've got all these sorts of light turquoise blue articles. And so he's on the talk page saying like, guys, this is how stuff should be done. Like we should be chill out, like this is the rules, this is how things should get done. And so he sort of brings that expertise about like how do we sort of like something that's always in the news and very sort of prominent. He brings that expertise and starts editing that on the sort of the nuclear disaster and the tsunami pages. So we're able to sort of migrate that expertise from one area of Wikipedia to another, and that sort of flexibility and the ability to do that is really sort of interesting. And sort of the socio-technical approach is able to sort of illustrate that these things are sort of highly clustered and very distinct for some editors, but they still make these transitions. Then you've got this other sort of editor whose trajectory is sort of much more sort of incoherent and sort of more hairball-y that we would see. Doesn't have sort of a distinct sort of structures before, but we still see that there's sort of some structure here that says that here is his stuff that he's doing on the Japanese articles, and then a lot of his work before is like on environmental organizations, international trade agreements. But again, you see the sort of migration of expertise where he's very much an expert in sort of nuclear policy and international trade agreements about nuclear issues, and bringing that to the nuclear disaster as well. And I mentioned before that this blue color was very sort of important. This is sort of my favorite case here, is that you've got this one editor who only edits, he doesn't do any of the sort of this background coordination stuff. He just wants to edit articles that are like just the content of articles. That's all he cares about. And so after the tsunami, you had all these towns and cities that were wiped out, and so he's editing all those articles. Well, all the work that he did before was about like Japan and Japanese pop bands and Japanese serial killers. And again, nothing would seem to qualify an editor who writes about Japanese serial killers and Japanese pop bands to edit an article about a huge natural disaster like this, but for the fact that he's obviously someone who lives in Japan and has a lot of sort of cultural familiarity with what are the towns and what are the landmarks that we need to update about this. And so we see, again, him migrating from this early sort of work that he was doing before down to migrating to the work on these affected towns and landmarks. And there's ways that we could lay this out again to show that not only did he go from editing this stuff to specialize in this for a while, but that he actually went back to doing what he was doing before. And I haven't shown that here. And so this was just a single case study. It's coming back. So this is just a single case study about sort of the editors and a single sort of set of articles around this Japanese earthquake and tsunami. But if we sort of begin to sort of look up another sort of level, we look at a whole class of articles. In this case, we'll look at a class of articles about airline disasters. We can sort of, if we do the sort of method that I described before, if we look at there's these different sorts of airline crash articles on Wikipedia, if we look at their article trajectories, their artifact trajectories of like which editors are modifying which other editors' work, we can kind of see by sort of visual inspection there's two very distinct classes of networks that come out of this, right? So at the top we have these sort of characteristics. So this is what networks often look like with the core periphery. It's sort of like the hairball. So these are sort of hairball networks on top. But at the bottom, these are also networks, but we'd never see networks like this in sort of nature or any sort of social system like this. But these are also networks that we see in Wikipedia. And The distinction between these articles is that these articles on top were authored as breaking news events, that the event happened and within like a few minutes of the event happening, people were jumping in and trying to edit this article. These were articles about things that happened years and years had passed, so that this airline crash happened like the mid-1990s, both of them, and so obviously there's no Wikipedia around, and so 10 years went by before anyone got around to writing these articles. But as a result, we see that the structure of these collaborations are very different. The ways that we produce the knowledge about these, there's the same sort of content. These are both airline crash articles, but the way that this knowledge was produced in very different ways. And we see those structures very sort of clearly. And so we can measure that with a variety of different sorts of like network measures that we could say, we want to sort of measure this hairballness of the networks, right? We want to say that this one on the left is more of a hairball than the one on the right. So we can operationalize that in like at least 4 different ways. There's many other ways we could do it as well. These are sort of very easy to compute and easy to sort of understand methods. And so we say that short diameters, like how wide is the graph? How many steps would you have to go between sort of different hops to say from one node to the other, the shortest, longest path. So the one on the left should have a shorter diameter. That these editors can just jump from one to the other. It would be relatively easy to get from one to the other if you computed that statistic, versus this person, you have to jump through every single editor. These are extremes, obviously, but they're illustrative because this one has a very short one, and the one on the right would have a very long diameter. Closest centrality would be a measure of how close are nodes to each other. Can they sort of reach many other nodes in a few steps? And if we measure that across, we average that across all the nodes in the graph, that this one on the left, the editors are sort of more close to other editors in general. On the one on the right, these editors are relatively far apart on average from other editors. And so the one on the left, we expect there to be more closeness. The one on the right, there would be less closeness. Between this is sort of this interesting idea like brokering, that you kind of connect editors who would otherwise be unconnected. But here we could think about betweenness not as sort of this classic idea like brokerage, but instead as like a measure of like fragility, that if you like took out that node, like would the graph suddenly become disconnected in a average sort of sense, that on the graph on the left, there's sort of overall low betweenness because there's no sort of single central node that is like a point of failure, versus the graph on the right, every single node is a point of failure. If you forget any one of them, they all have very high sort of betweenness centrality. And then finally, clustering. This one is more clustering. More of its editors work with other editors who they themselves have edited with. The one on the right, no one is editing with anyone else except the person immediately before them. And so if we look at we do a statistical model and we ask, are these sort of breaking news articles different in aggregate? If we look across this whole set of articles about airline disasters, we do see that depending on how long it takes for that article to be created, we do see that there's shorter diameters, there's more closeness, there's less betweenness, and more clustering. So across all 4 features, we find evidence that, in fact, these breaking news articles have more of this hairballness pattern than non-breaking articles, right? So these breaking news articles are, in fact, sort of structurally different from non-breaking news articles, and that's largely a function of how much time it takes for those articles to be created. But then we also have this idea that these trajectories also capture something about the temporality of these collaborations. That if we look at some of these editors, join and start editing at a particular point in time, the collaboration has a characteristic sort of pattern. Like in the early stages, maybe it's highly clustered and looks something like this, where again these are editors who are working with each other at a very sort of early point in time. But if we look at sort of the collaboration much later, like this again is the Japanese example, that has perhaps a very different sort of structure. But even though it's the same article, so that the way that they're collaborating on these articles may itself be changing over time. That as time goes on, they may look sort of highly clustered and hairbally very early on, but later on, it may in fact sort of revert back to sort of like how non-breaking articles are edited. So we can again sort of estimate a model down here and say that is it the case that the way that the structure of these collaborations at a later point in time, if we just subset that data, do those collaborations later on look very different from those collaborations sort of very early on? In fact, that we do. We see that they sort of regress to the mean, that they begin, as time goes on, these breaking news articles, this clusteringness of them only occurs in the immediate sort of aftermath in sort of days 0 through 7. But if we look sort of later on, these articles begin to get longer diameters, they begin to have less closeness, they begin to have more betweenness, they begin to have less clustering. So here we again sort of find evidence that this way of collaborating, by using sort of trajectory method, we find that this way of collaborating is very sort of unique to the immediate aftermath of these events, that we see that that sort of effect begins to go away as time goes on, and they begin to look more and more like normal collaborations. So the differences actually do not persist over time. And so the sort of last case I want to talk about here is we've talked about like a single case about an article and some of the editors who contributed to it. Then we looked at sort of like a class of like all these articles about like airline disasters. But if we begin to look at like a set of like 3,000 articles about hurricanes, we look at articles about airline crashes, we look about like accidents and industrial disasters and wildfires and health outbreaks. We look at like really broaden the scope to include all these different kinds of articles on Wikipedia. We can ask some other sorts of questions. And so we can begin to imagine, like, if we layered these trajectories one on top of another. So before we were only looking at trajectories in, like, within a single article. So within the Japanese earthquake disaster article, for example, right? But what if we said, well, there's a set of editors who edit this article. Well, maybe some of them also edit articles about airline crashes. We can, like, layer these sort of trajectories one on top of each other and, like, look at the union or the intersection of these. And what does that sort of trajectory look like? And so we can say that on one article, maybe editor A works with, modifies the work of editor B, and on article 2, editor A modifies the work of article B. But these relationships on article 1 and article 2 both occur on like breaking news articles, and so we can say these are the same editors. They're going to actually have two different kinds of relationships, and we can collapse those two different kinds of relationships into a single relationship where there's a weight. They work together on two different articles, but on those two articles, both of them, or 100% of that work was done on breaking news articles. So we'll give it like a redder color. And so we can color these edges by different sorts of colors to say, like, maybe the bluer ones are non-breaking articles, so they work together on a breaking news article and a non-breaking article, and so they still work together in two articles, but we'll give it a different color because it's a mix of different types of articles here. And so if we again run this across all 3,000 articles, we get a nice picture like this. And so, again, these sort of gray nodes here are the editors. And these are editors who've interacted across two or more articles. And so this is the sort of the zoomed-in giant component of this. And so the redder colors that connect some editors to other editors mean that they interact a lot on breaking news articles. And if they have a blue color, that means they interact exclusively on these non-breaking articles, right? And then we've got sort of these colors that are like green, which means they sort of interact on a mix of like breaking and non-breaking articles. And so we see there is, in fact, like a strong sort of core of editors here who edit across many different sort of breaking news articles. They work exclusively together on breaking news articles, given this sort of red color. And then there's other editors, who appear to work together repeatedly, but on non-breaking news articles, and so on. But this cluster down here is sort of really interesting and illustrative. So these are editors, right, who are working together. We've got records of them modifying each other's work across many different kinds of articles. But it's extremely dense. It's almost as dense as we would see up there, but it's also removed, that they're not actually working with those editors or modifying those editors' work. They're modifying each other's work across many different articles, but not necessarily modifying these other editors' work. They kind of just work by themselves, and they're relatively isolated, but not completely. But it's also that there's interesting color, right? They're not working only on breaking, and they're not working only on non-breaking. Or there's some who work only on breaking, but there's a lot here who work on like a mix, almost a perfect mix of breaking and non-breaking. And so these are editors who edit stuff about tropical cyclones. And so this is like a really interesting subcommunity on Wikipedia where Wikipedia has these wiki projects where people sort of get really excited about editing articles about military history or roads and bridges. And so there's a group of folks who just like to edit or create articles about every single hurricane and tropical cyclone that's ever existed. And so they write this in a very formalized, like standard way that the storm developed as a squall off the coast of Africa and then moved off and became like a tropical depression with this kind of barometric sort of characteristics and so on. And so they just have this sort of like, almost like a perfect way of like just writing these articles, this copy and pasting them almost, and then filling in just like what changed for these different articles. And so we see is that these people are editing, they kind of show up in my breaking news corpus because obviously there's breaking news articles. These hurricanes are breaking news articles often, but these people are also working together on because they care about hurricanes. They don't care about breaking news articles. So they're also editing these other articles about hurricanes that happened 50 years ago. But they're working together. And so what this method has really uncovered is by identifying these trajectories overlapping in this way, we've highlighted like a community of practice. And this is what we would call like a community of practice in a very sort of traditional way. That this is people who are like kind of jointly attending, the same sort of topic, and there's ways to sort of join the community and erect boundaries that they're not sort of part of the rest of the community, engage in particular kind of work that they care about that's differentiated, and so on. And so these trajectories approach that I've sort of proposed and sort of I think that I've tried to demonstrate here we've gone from like this very sort of abstract idea that there's sort of these event logs where sort of we can see that someone edited after someone else, and we've arrived at this place where all of a sudden that we can begin to sort of uncover these sort of really complex and interesting sort of anomalies in this data by using this method. And so I just want to wrap up here with a discussion so that these event logs are ways to sort of narrate changes to artifacts, Wikipedia articles or GitHub repositories and users over time, right? These are the history of someone becoming an identity or an article sort of becoming more complex or something like that, right? That we can go through and look at in previous points in time of what these articles or what these artifacts, what these users were looked at and are doing in previous points in time. These event logs are pervasive throughout lots of different socio-technical systems. We see them in GitHub, we see them in Wikipedia, we see them in Scratch, we see them in Reddit, and so on. We can go through and find these data almost everywhere, and yet we don't sort of realize the potential that we can begin to build relationships out of these, right? That if we look at these sort of temporal adjacencies, the fact that I work immediately after Scott, who works immediately after Andreas, all of a sudden we can begin to sort of do some really interesting things about creating these trajectories that have these really sort of complex and interesting behavior, right? That they collapse this sort of very large-scale data into this sort of nice sort of graphical representation that we can then begin to do sort of traditional sort of social network analysis things on, right? And that they capture this idea of the stigmergy, that there's sort of, we've got this accumulation, this gradual accumulation of effort, of individual contributions, create these sort of very emergent sort of complex structures. Again, like we're not sort of looking at the sort of content level features that we were working on the same sentence or anything like that, which is the fact that I edited after Andreas or something like that, but by aggregating these sorts of interactions up together, we get these sort of very interesting and very complex structures that are non-trivial, and they reveal these sort of the patterns within these trajectories begin to highlight sort of the social and temporal context of work, right? That we see that in the community of practice with the sort of the hurricane editors. We see that there's sort of more active editors are not sort of deeply involved in, they join the article very early, right? They had the blue editors, they joined very early and they stopped editing, right? There's sort of these interesting sort of behaviors that we capture in these contexts of work that people were involved and motivated to work very early, but weren't in fact motivated to sort of continue to work going forward. And so what I think is most sort of powerful here, and this is probably the hardest one to read, but that trajectories that also expose sort of regularities and anomalies for sort of like follow-on qualitative analysis, that we see that there's sort of the regular pattern in how these networks sort of behave, but then we see these anomalies, that there's people who are like highly central, like, well, what does that mean? Like, those editors are coming from somewhere. They had some work that they had done before. They had some work that they were doing afterwards as well, so we only capture that in a single snapshot, but then we can begin to sort of unpack that in a much more sort of rich way, where we see these anomalies like this sort of group of editors who are working together but weren't necessarily working strongly with a lot of other people on all these different breaking news articles. That's an incentive to kind of dive in there and look deeply at what's going on in there. And so we were able to sort of unpack from these trajectories some of these sort of interesting anomalous sort of structural features that we can then begin to sort of use to then motivate sort of follow-on sort of qualitative analysis. And so I think this approach, the socio-technical approach that I've discussed here, is an interesting sort of like mixed method sort of thing, right? That we can both use it to sort of do it like data mine now, these extremely large scale sort of databases that we have that are pervasive and all these different event logs that we have. But we can use that to sort of collapse that down into something that's relatively easier to comprehend. We can make a network out of that. We can begin to run sort of the network analyses on that. And then we can begin to see there's the anomalies that then we can use to motivate some interesting qualitative analysis and kind of tie these things all together, really understand the complexity of these systems. So with that, I'll wrap up, and thank you guys for your attention. I'll take questions.
I have kind of a conceptual question.
Sure.
So you're sort of framing this whole entire thing as collaboration between people.
Right.
But then the relationships they're actually looking at are proximity in time.
Mm-hmm.
So like you might edit an article that I had previously edited, and then I might never go back to it. Like, are we really collaborating on something? It seems to me that this is more about like participation. So like what distinguishes breaking from non-breaking articles is the patterns of participation, not necessarily collaboration.
So, right, so there's probably an imprecision in like the language I use, and I think that, we can sort of split hairs here about like sort of coordination and collaboration and all these sorts of things, right? But it's important to sort of like separate those out, absolutely. But one thing that I think you brought up though is the fact that these relationships are actually really implicit. That like in social network analysis, we often assume that like we make an active choice to email someone or to talk to someone. Like that's an agentic, like I decided to talk to you but not someone else. But in fact, what this method is sort of uncovering are these sort of more implicit or like unassumed ties. Like I might be modifying an article, not know that it was your version of the article. And so that's just maybe purely coincidence. Maybe that's all we're capturing. But if it was sort of really all pure coincidence, then you would just sort of see these random graphs where sort of nothing's really happening. But what we're actually seeing is something very different, where we see that there's these patterns of activity, that there's like you're engaging and then I'm engaging, and then the fact that you don't engage anymore says something about how this collaboration is working, right? That you chose not to engage anymore. You're not sort of paying attention to anything, that this isn't something that you care about potentially. It could be, and it captures something about, do we pay attention to each other's sort of work as well, right? And so I think that in the sort of very micro level, like a lot of this may just be sort of coincidental sort of ties, right? But I think that by sort of, there's lots of data here, you begin to mine that up, you begin to see sort of that begin to wash away, and so there might be like a baseline level of like randomness in this sort of approach, but begin to see these sort of structures emerge that suggest there's something very much non-random and non-coincidental about these ties.
Yeah, so as a second question, so you started out sort of motivating this by like sequence analysis kinds of things. Have you done anything with like the whole set of network models that like network relational events?
So I haven't done anything like that. So that's sort of the next approach here, is that, so having just done these sort of this admittedly just purely descriptive sort of work here, saying like you can create these kinds of networks using this sort of approach, they have these sort of very complex features, but all of a sudden we've got networks now that look like networks that we often see in other sorts of contexts. So now let's begin to sort of bring in these other sort of methodologies that we have in social network analysis, do statistical modeling, that we can look at what's the likelihood of some people creating ties with each other and so on. How do these things sort of evolve? Can we create sort of like Markov chains, like people making decisions about when to sort of jump in there and so on? Yeah.
Because I think that perspective could be really interesting, because like the sequence of ties is explicit in that model versus this where you're kind of obscuring the timing of the edges. Not really, because like forward paths are forward in time, but like they're all kind of in one thing together, versus that kind of framework where you think about like not necessarily, I mean, yes, a network, but a set of nodes where edges occur discretely, like over time.
Right. So these networks are sort of unique. I don't have the sort of graph theoretical, like mathematical background to like explain exactly what the right word would be, but like they're unique because like you can actually follow a path on that network, which is the editing sequence. But you can like walk this graph and like show like how sort of who's touched it when, right? And so that creates some biases maybe in terms of like what kind of ties can or can't exist, right? But there's, I don't think people thought through like how to model this as well, so it's exciting.
Yeah. That's a whole other thing we should do too.
Thank you. Yeah.
I totally dig the approach of getting down into sort of the sort of action in the network to, I don't know, to sort of bridge the Barabasi-Bankler gap. Very cool. And also, I'll sort of applaud you, and it's hard to scale that up, right? Because you're focused on sort of individual level action. So it's cool that you were able to scale that up to like multiple thousands of events. I guess the question then is just coming back to the, how does it relate to Bankler's kind of what's important in society? And so I'm just curious, I don't know, for your thoughts on what do you think are the tightest operationalizations of this work to the sort of Bankler-esque what's important for society? Like, is it about, we can understand how different networks, in terms of the sort of activity of the editors, enable societal level self-reflection or efficiency or sort of information spread, or, I mean, what are the, I don't know, does that make sense?
So one thing that was motivating this, maybe this will be a roundabout way of getting to that, was that, so Bankler talks about sort of like these forms like network sort of knowledge production, right? But when we talk about like a single artifact, like how that was produced, like we have no way of sort of unpacking that. So I think that this is one way to begin to see that in fact different knowledge artifacts are produced in very different sorts of ways, and sort of this complicates this idea that like we just call a network that's all of a sudden like we can just use that as a framework to understand like these things are all different, that actually within the sort of network form of like knowledge production, there's actually sort of really interesting sort of differences in how those things are done. And so then if you want to get into sort of these societal level questions, it's like you can begin to sort of get at questions maybe of efficiency, like are there some ways that, you know, is the work that's being done that's sort of highly clustered here really redundant? And maybe it is, because we saw that like not a lot of like effort was, or always only a minority of people who weren't doing most of the heavy lifting were actually making like the biggest changes to these articles. So in fact, the work there was sort of, it captures that modularity and granularity that he talks about a lot, right? But to get to that question of sort of those outcomes that we care about, I mean, it might bear on sort of how would we go about designing systems or designing sort of feedback mechanisms that sort of reward people for assuming certain kinds of social roles in these sorts of collaborations, to incentivize them to assume roles that make them more sort of coordinative or interact with many different kinds of editors, or highlighting the fact that they're engaged in a particular way of collaborating and not, or maybe that's problematic or that it's not, and that and so getting back to the sort of Bankler question, that, you know, we usually provide that feedback like monetarily or something like that, but here we can begin to use like the mine the information, mine your history to say something about and valorize that in a certain way, to say that you're engaged in a particular pattern of collaboration, that we know that that leads to these particular outcomes, that maybe I differentiated it on like breaking or non-breaking, but maybe like some patterns of collaboration lead to very high quality articles or low quality articles, and we want to replicate that. Maybe that's just a feature of how we generate high quality knowledge artifacts, that we see maybe this hairball is just like why some collaborations are successful or not, because we're part of a community, that I know that Andres is looking at what I'm doing and that I'm looking at what you're doing, so we feel like there's like the work that I'm contributing is kind of going off into the void, but like other people are going to sit down and modify it as well. So in all those sorts of ways, I think that we can, this framework suggests ways that we can both study different ways of like how valuable sort of these artifacts could be to get at that outcome question, that there's differences maybe, that these structures might predict different kinds of outcomes, may predict different sort of quality of these artifacts.
Kind of connect to that, so like, again, like Bankler, one of the focuses of his work is to come up with like design patterns for, you know, cooperative systems and so on, design levers as he calls it. From the specific set of cases that you looked at on breaking news, what are the kinds of take-home messages that you will give to say if Wikipedia were to be redesigned to just focus on breaking news events, right? I assume there's a lot of challenges with like what's notable and what's not notable and so on, but like what are the most important kind of lessons that you could get from some of the work that you've been doing for breaking news?
Sure. And so I think that the examples of the editors that we looked at there, the people who are editing the articles about Japan or the editors about Harry Potter, I think that in traditional sort of organizations, you know, the stuff that Bankler sort of critiques is that in traditional markets or hierarchies, we would say, like, you're not allowed to do that. You shouldn't be able to translate that expertise to someone else, somewhere else. You would have to go through an administrator. You need an accreditation. Or you need someone to say, like, it's okay for you to go over and edit these kinds of articles. And so in this network sort of way, we can begin to see the sort of the flows of this sort of expertise into new domains that you wouldn't predict would be it. And so what's hard then is like you might be able to sort of create a recommender system to say that like, oh, it looks like you like editing talk pages a lot. It seems like you're a very good sort of discussant or sort of arbitrator or something like that. We're having like problems here. Would you mind coming over here and like helping out with this discussion thing? And so there's maybe like a design lever around sort of how do we do match sort of tasks to people better by looking at these sort of patterns of how they worked before, the kinds of work that they engaged in before. And so we could begin to sort of maybe do some sort of matching like that. Does that get at that? Yeah.
Cool. So, thank you very much.
All right. Thank you guys.